Welcome back, everyone. Today we're going to have a workshop on logarithmic functions. In this workshop, we have four objectives. Objective number one, I can graph and determine the effects on the graph of a logarithmic function when f of x is replaced by all of these transformations. Question number one, what is the transformation of the function ln x minus 2? All right, let's try to recall this. Whenever you have a plus or a minus, it is a slide, it's a translation, it is a shift. If the plus or minus is inside the parentheses, it is a horizontal shift. Now, because this is outside, this is a vertical translation. This affects the y values. Therefore, the answer here is A. It is a translation 2 units down. Question number two. A student graphed f of x equals log x and g of x equals f of x plus 5, where the 5 is inside the parentheses. On the same coordinate grid, which statement describes how the graphs f and g are related? It is best to use Desmos on this one. So let's go ahead and plug. Okay, so this is the parent function, y equals log of x. All right, so this is what happened to your graphs. Your graph had shifted 5 units to the left. And so looking at all these answer choices, it's talking about the vertical asymptote. Your vertical asymptote, therefore, is here already. It's by x equals -5, and it had shifted 5 units to the left. Therefore, the answer here is B. Right, so number three, graph the function f of x equals 4 log x. Which of these statements are true about this function? So let's go ahead and plug it in. All right, so let's go ahead and begin the analysis of this question. Letter A says the function includes 3, comma 2, which is absolutely not. Okay. And letter B says it has a y-intercept of 0, -5. You know that that's not going to happen because this is your asymptote. The asymptote is the line that your graph approaches but will not ever touch. So that is not ever going to happen. So that does not exist. So let's now go to letter C. The function is decreasing as x moves to the right. And you can see that clearly that your function is increasing as it moves to the right. It's not decreasing. So the answer here is letter D, which is that the function is increasing as x moves to the right. Okay, number four. Given the function f of x equals ln x and g of x equals 1/2 ln parentheses x minus 3, which of the following describes the transformation from f of x to g of x? Okay, so let's try to recall our rules of transformation. You'll know that when you're multiplying a number with your function, that it is either a stretch or compress. When you're multiplying a factor outside of the parentheses, then it becomes a vertical stretch or compress. Because your factor is less than 1 but greater than 0, then this becomes a vertical compression of factor 1/2. Then this inside the parentheses of subtracting a 3 is a horizontal shift or a horizontal translation 3 units to the right. So the answer here is that this is a vertical compression of factor 1/2 and a horizontal shift 3 units to the right. The answer here is C. Let's go ahead and confirm this on Desmos. This is the graph for ln x. And the blue graph is your transformed graph. As you can see, it's been vertically compressed with a factor of 1/2, and it also shifted 3 units to the right, and that can be confirmed by 1, 2, 3 right there. Moving forward, objective number two, I can analyze key attributes of logarithmic functions. Question number one, graph the function f of x equals ln x minus 5. What is the x-intercept of this function? Let's go ahead and plug this in on Desmos. Okay, so this is the graph and your x-intercept is approximately 148. So let's now go ahead and do this by hand. Okay, so this is our function. We will have to set y equals 0 in order for us to solve for the x-intercept. Now add 5 on both sides to isolate your x. Right now, we can solve this by expressing them all as a power of base e. And then now e to the ln x is just equal to x. And so now we have found our x-intercept, which is e to the 5. However, e is a number by itself. Let us now go back to Desmos and plug in e to the 5 and see what appears. So as you can see, e is an irrational number with an approximate value of 2.7. Let's go ahead and raise this to a power of 5. Okay, so this confirms our x-intercept that e to the power of 5 is 148 approximately, which is 148 on our graph as well. The answer here, therefore, is letter D. Question number 2. Given the graph of y equals a to the x, find the domain and range of y equals log base a of x. So let's take a look at this. The domain, I see arrow on the left and on the right, so that is set of all real numbers. And then your range, starting from the horizontal asymptote, which is y equals 0. So it's from 0 all the way up to positive infinity. The answer here, therefore, is B. And as you can see, this is not including on the range, it does not include the 0. And it is because that your y equals 0 is your asymptote. So once again, an asymptote is a line that your graph tries to approach but will never touch. Therefore, it does not include 0. Question number 3. Consider the log function below. F of x equals negative 2/3 log base 2, parentheses x plus y minus 4. What is the asymptote of the function? Let's go ahead and plug this in on Desmos. Okay, so as you can see here, the asymptote is x equals negative 5. The answer here is A. Once again, this is a vertical asymptote. There is no horizontal asymptote. Let's now go to number 4. Graph the function f of x equals ln parentheses x plus 3. What is the y-intercept of this function? Let's graph this. All right, so this is the graph of your ln x plus 3, and the y-intercept is approximately 1.099, which is not A, which is not B, and which is not D. So let's try ln 3. Plug it in. So the answer is C, which is 1.09, and this y-intercept is 1.09. Objective number 3. I can solve equations using logarithms and determine the reasonableness of a solution to a logarithmic equation. Number 1. Solve for x. So your first step in order to solve this is to divide both sides by 3. Now at this point, you will have to express this into its exponential form. All right, now solve for x by dividing both sides by negative 4. 7 to the power of 0 just becomes a 1. So our answer is x equals negative 1/4. So our answer is A. Question number 2, solve for x. 2 minus 15 log base 6, x plus 2 equals negative 28. Let's go ahead and do this by hand. So our first step to this, to be able to isolate our x and solve for it, is to remove the 2 on this side with the additive inverse of minus 2. I will just do the shortcut, move this to the other side, and change the sign. Now we're going to combine the negative 28 with the negative 2, making it become negative 30. We will now divide both sides by negative 15. So now therefore this negative 15 cancels out with this negative 15, leaving us with log base 6 x plus 2 equals 2. And then now we're going to transfer this to its exponential form. And then now we will just solve for x. So 6 squared is 36. To isolate the x, we will have to subtract 2 on both sides. Or we can simply move the positive to do the other side, but it will change to a negative 2. And the answer is 36 minus 2 is 34. Our answer is C. Objective number 4, I can work fluently between logarithm form and exponential form. Question number 1, if log x base x of y equals 2/3, which of the following is true? Okay, let's go ahead and review how to change log into exponential form. We take the base, we raise it to the exponent of 2/3, and we put it equal to this argument. So therefore, it's x to the power of 2/3 equals y. It goes around. So x to the power of 2/3 equals y is C. Question number 2, evaluate log base 3, 729. In order to solve for this problem, we're going to have to move this into its exponential form. So take the base, put it to the power of x. Then make it equal to 729, and you will have to take 729 and express it as base 3 with all these possible exponents. All right, so this is going to be 3 to whatever power that is, and this is when it's best to use Desmos. All right, so here you can see I have plugged them all in on Desmos. 3 to the power of 3 is 27, 3 power 4 is 81, 3 to the power 5 is 243, and 3 to the power of 6 is 729. Therefore, your answer is D. Number 3, solve for x. 6e to the power of 4x equals 120. Let's go ahead and do this by hand. Okay, so our purpose here is to solve for x. Therefore, x must be by itself. In order for us to do that, the first step is to remove the 6 by dividing both sides by 6. So we're now left with e to the power of 4x equals 20. And you know that when your x is on the exponent, then we have to also express this in base e with an exponent, which is not possible. Therefore, we use the log. So from exponential form to logarithmic form, this is going to be your base of the log. So log base e. 20 is going to be your argument. So now it goes to the log base e of 20. And your exponent is going to be your answer on this side, like such. Now you all know that log e is the same as ln. So log base e of 20 is just going to become ln 20 equals 4x. And now we can isolate the x by dividing both sides by 4. And so now your answer is x equals ln 20 over 4. Do not make a mistake of canceling out or simplifying 20 by 4 because ln 20 by itself is a number. So do not divide 20 by 4. So our answer here is letter A. I just wanted to show you that ln 20 is approximately 2.9957 and ln 20 over 4 is, all right, so that those are the equivalents. Our answer here is A. Number 4, what is the logarithmic form of the exponential equation 1/4 power of negative 3 equals 20? So again, it goes around. This is your base, this is your argument, and this is your answer. So log base of 1/4, which is right here, argument of 20 equals negative 3. So therefore, your answer is letter A. Number 5, which exponential equation can be used to solve log base 2x 776 equals 5? So again, it goes around. This time we're changing log to exponential. So this is going to be the base of your exponent. This is the power, and this argument is your answer. So let's look for that. 2x to the power of 5 equals 2x to the power of 5 equals 7776. The answer is A. Question number 6. If log base 10x equals negative 3, what is the value of x? Let's go ahead and do this by hand. So once again, the 10 is going to be the base of your exponent. This is going to be the power, and this will be the answer. So 10 to the power of negative 3 equals x. All right, and then we're just going to solve this. A power of negative has to be moved down to the denominator so that it turns to a positive. So it looks like this. So this is the value of your x, 1 over 1000 or 0.001. Last and final example. If y equals 8, what's the value of x in the equation ln x to the 8 equals y? Let's go and solve this by hand. So we substitute 8 in place of y, and we emphasize that the base of ln is e, and then we're going to change this to exponential form. E to the 8 equals x to the 8. Get now the 8th root of x to the 8 in order to isolate your x. Whatever you do on this side, you do on the other side. This will now cancel out, and so your x is equal to e. So our answer is C, and good luck on your test.